All right, in example 10, we're going to set up the definite integral that would calculate the area of each region below. So I'm setting up my actual definite integral. So the first thing I'm going to do is draw my integral symbol. And then I'm going to find my lower bound and my upper bound. So my lower bound on this is going to be 0. And I'm just going to count. This looks like it's going by 1. So 2, 3, 4, 5. So 0 to 5. And then I need to figure out what function I am doing. So we'll notice that the function, it just looks like a horizontal line, which is a horizontal line is y equals 3. So our function is 3. And we know that all those little rectangles that added up, their width is the dx. So this is the width, represents the width of the rectangles. All right, in B, I'm going to set up my integral. Now there's a couple of different equations going on here, so I'm going to actually do two separate integrals, I think. So I'm going to go with the integral from -4 to 0, and from 0 to -4. I'm sorry, not to -4, to +4. All right, then I need to figure out this equation right here. So it looks like it's a line. So I know I need an mx plus b. It looks like my y-intercept is 4. And then my slope is down. It looks like it's down 1. Sorry, it is up 1 over 1. So it looks like it's just x plus 4. And then again, we put the width of the little tiny rectangles. The other side, I know I need an mx plus b again. And my b is still going to be the y-intercept of 4. But this time my triangle is down 1 over 1. So I've got a negative x plus 4 with a dx after it. And 11, I have to sketch and shade the region whose area would be given by the definite integral. Okay, so when all else fails, you can always plug in values and plot points. Okay, this happens to be a line, so I'm going to do the line. So I'm going to start at 5. So I know my y-intercept is 5, and I know I've got to go up 2 over 2. Ooh, I'm running out of space, right? So I could also go down 2 over 1 the other direction. That would still get me a positive slope line, which is good because I'm only supposed to go to 0, and I'm supposed to be at -2. So I'm going to do that again. And so this right here would be my line, and then the region that I would be finding the area of would be this. Remember, it's only to the x-axis. Now, the next one's a little bit trickier because you probably don't remember that you maybe did some circle equations in geometry. So what I'm going to do is I'm going to actually plug some values into that. So I'm going to use a t-chart. So I need -3. I know I need 3. I probably should have something in between, so I'm going to pick 0 because it's easy. So when I put -3 in, I get it would be 9 minus -3 squared, which would be 9 minus 9, which is 0. So I know I have the point -3, 0. Then I'm going to put the 0 in there. So I've got 9 minus 0 squared, which would be 3. So there's that point. Then I'm going to put in and I didn't take the square root of that, did I? It would still be 0. All right, then I'm going to put in the 9 minus 9, or 3 squared, which is still going to be 9 minus 9, which the square root of that is still 0. So what ends up creating is a half circle, or a semicircle, and this would be the area that we would be finding the picture of. Oh, we were apparently supposed to calculate the area, to use geometry to find the area, so I guess I better go do that, huh? So let me go back to this first one here. That's a trapezoid, right? So we know we've got base 1, which would be this. So that's 1 high, plus base 2, which is 1, 2, 3, 4, 5 high, times the height, which it's sitting on, is 2 divided by 2. So those cancel. My area on that one would be 6. This one is a semicircle, so we know that the area would be 1/2 the area of a circle, so 1/2 pi times the radius squared. My radius length is 3, so we would have 9 pi over 2. Okay, let's look at C. So C is an absolute value equation, which actually we saw one in an earlier example, I just didn't set it up that way. So what this is saying is I've got an absolute value that is shifted up 1 and upside down. So I start here. I just start at my y-intercept of 1. Notice it's scaled by 2s. And then I count down this slope that's in front. That's kind of my shortcut. Down 1 over 1, down 1 over 1, both directions. Okay? So that's what that's the picture, but look at this. We're only supposed to be going from -1 to 1. So we actually have it, but so that's the area we're having to do. I have a nice little triangle there, so I know a formula for a triangle is 1/2 the base times the height. The base is 4. The height looks like 2, so my final answer would be 4.